when you look at the electronics and software architecture that's in every vehicle sold in the United States, with the exception of the Rivian and Tesla, the beginnings of that network architecture date all the way back to the 1960s. And they go back to the very first piece of electronics that existed in the car, the first microcontroller. And that first microcontroller was alongside of a fuel injection system. So for those car enthusiasts remember like Bosch, K-tronic, and all these very early 50, 60 year ago electronic fuel injection systems. That was the first time the car went from a fully analog thing to having its first piece of compute inside the car. And at the time, this is the 1960s, car companies said, this isn't our core competency, we're not going to develop this ourselves, we'll work with companies like Bosch to build these systems. And that was the first emergence of what we now call ECU. And that was an ECU, an electronic control unit, that was focused on function or domains. We now call that's a domain controller, that ECU is a domain controller. And then, not in a planned way, not in a way that was architected, but nonetheless it happened over the next 60 years. All these different areas of the vehicle started to add intelligence to themselves. So you would add a microcontroller with your HVAC system, you'd add a microcontroller with your seats, and everything that was at any form of intelligence, more control logic, started to have these little ECUs. And again, it wasn't like overnight, it was over a half a century. And fast forward to today, a modern car will have 100 to 150 of these little ECUs, these little domain controllers. And it's like an awful field of weeds. Each of these ECUs is its own hardware stack. Each has its own little island of software. That island of software is made by a supplier. The suppliers, in fact, generally don't write the software themselves. They hand it to a third party, often in India. And so the layers of abstraction between the actual code and the manufacturer are 2 to 3 levels across 100 to 150 different controllers. And that's a mess. It's hard to manage, but it was sort of livable. You could live with it in a world where the software was locked, meaning you had to do all this incredible coordination effort. So if you were involved in software manufacture at an OEM, your job would be coordinating amongst many different suppliers. Those suppliers would be building these ECUs. Those ECUs would communicate over a CAN network, and you'd lock it. And then along came this idea of, what if we wanted to update it? And so let me use just a very simple sequence to illustrate the point. If I were to walk up to a Rivian, or to any car, and the sequence of events that occurs, the lights change orientation, there's an audible noise in the exterior of the car obviously unlocks, the security systems disengage, the seat adjusts, the HVAC comes on, something happens with the music, the screens come on, let's see what else, the car may lower. And if you look on average, the number of companies involved with managing that sequence of events that occur when you walk up to the car for it to unlock is around 15. And so if you want to change that sequence, the exercise is like a mind-numbing process of coordinating amongst 15 different companies. Whereas in a Rivian, I could change the sequence of events this morning. We could agree right now that every Rivian on the road will have a different unlock sequence, and we could have it out by the afternoon with an OTA, because we control the entire stack. And so what Rivian did differently in Tesla and these more than 5, less than 10 Chinese companies is that rather than having this distributed set of many, many ECUs, let's have a centralized compute platform where we own obviously the whole computer, but importantly we own the whole software stack. So we own the operating system, the real-time operating system, we own the applications layers, we own the middleware layer, and by owning that entire platform, you can then create new features very easily. There's less than 10 companies, car companies in the world that have this. There's 2 that have it outside of China. And for us, it was sort of an obvious decision. If you're designing a system from scratch, you wouldn't say, I'm going to go coordinate with 100 to 150 different suppliers to make small little islands of hardware and small little islands of software, have to manage it through these horrifically tall stacks of requirements documents that have to get disseminated across all these different suppliers. You'd say, I'm going to build computers, I'm going to build a software operating system, and I'm going to build applications that are have 6 presets that will move forward at this speed, they'll go down at this speed, they'll come up at this speed.